Greetings, class. This is Mrs. McCoy, and this is the answer key to homework from Test 3, Lesson 1 and 2. So part of this one was that I saw when I looked at your work was failure to read directions or follow directions. So simplify the following square root, use absolute value notation when necessary. And the pop-up, which I didn't copy on this one, specifically said you had to follow the notes. And so the notes said that you needed to write this as a quantity square. And we know that 4 squared is 16, and x squared is x raised to the second power is x squared. So that was the first thing I wanted to see. And then the next thing was, because it was a quantity, well, that sort of didn't go very well. Because it's a quantity, that's what allows you to come in here and say square root undoes the square power and leaves you with your answer. It did say use absolute value as necessary, so this one would have needed the absolute value symbols around the x because of that. One of the errors that I saw was something like this. So this is an error to come in and do this, because when we do that, it's all about the quantity. It's all about it being in parentheses. If you do that, then you're saying that writing it that way would imply that the 16 is also a part of a quantity. And what y'all did was then found the square root of 16, and you said you had already taken care of the x, which is a true statement, but the math doesn't back that up. So you can't do it that way. It does have to be in parentheses. All right, next, number 2, simplify. Remember to use absolute value notation when necessary. If it cannot be simplified, state this. And the instructor tip said write in exponent form and radical form before answering. So exponent form, oops, sorry, I started the wrong one. There we go. So exponent form would be that, sorry, I'm still not doing it right. I'll try one more time. Okay, there we go. There's exponent form. And to simplify using exponent form, we know that 6 is evenly divisible by 2, or we could say that 2 goes into 6 3 times. Okay, so this is exponent form. And the reason I wanted you practicing exponent form was so that later when we get to the problems that have numbers and variables, that we're able to do that shortcut that we did right there. Now we could have also done it the same way we're going to do our radical form, and we could have said, based on that being a 2, the denominator being a 2, we know that 3 times 2 is 6, and that half of 2 is 1, and so that would also leave us to the 1/3 power. We didn't do that one as commonly. We were really focusing on that. Now, the other thing from the pop-up, radical form, and again, I'm looking for the same thing in radical form. Since that's understood to be a 2, I was looking for you rewriting this as a quantity square. 3 times 2 is 6, and then there's your shortcut. So those would have been steps that I was looking for. And I do prefer you working vertically. When I did my cut and paste, I didn't really leave myself any space. I didn't have the time to retype this. So some of my work is vertical or horizontal, which is not what I want. All right. Show step of rewriting the radical and the step of using the negative in front of the radical. So I am looking for several steps here. Now there are some apps that take care of the negative under the radical without showing a step. What I'm looking for, just like question 1, is that you rewrite this as a quantity cube. So when we check the cube root of 343, all right, let's see if I'm going to be able to figure this out. Negative 343. All right, let's see, that's not going to do it. Parentheses, 343 negative, there we go. Close my parenthesis, raised to the power, parenthesis, 1/3 power, and enter. There we go, 7. So -7 quantity cube. That's the first thing I was looking for. We know that the cube root undoes our cube power. We have the negative out in front of the radical. We have the negative inside the radical. And the opposite of -7 is +7. All right, question 4. All right, and then question 4 says, again, do radical and exponent form. So we're going to first rewrite our problem. So we're ready to do both. And cube root of -1000 would be -10. So when I ask you to go to exponent form, you've got -10 to the third, and parentheses or brackets. We're going to raise that to the 1/3 power. 3 times 1/3 gives me 1, so that leaves me the -10. And radical form, which we already have written, and because it's a quantity cube, cube root undoes my cube, and it leaves me the -10. And I'll stress again, got to have the parentheses, you've got to have the parentheses, you've got to have the parentheses. Okay, exponent and radical form once again. So, and probably radical form would have made more sense to start with. Cube root of, or the 5th root of 1024, and I believe that's a 2. No, can't be 2. How about 4 raised to the 5th power? There we go, 4. Okay, so 4 raised to the 5th power. And we got the negative out in front. And so radical form, 5th root undoes the 5th power and leaves me -4. Exponent form, and 5th power, 1/5 undoes the 5th power and leaves me the opposite of 4. All right, simplify. Assume the radicand under the radical is not formed by using negative quantities, so the absolute value notation is not necessary. And again, write as a quantity raised to a power. The variable was already set up for us, but quantity means I need parentheses. That's the wrong exponent. So 4th root undoes the 4th power and leaves me my 5c. I should probably go back and double check. I don't remember if any of those needed absolute value. Let me go back and look really quickly. Okay, and I did go back because I did forget in one place to make sure I read my directions. So this one was, I said it when I looked at the problem, but I didn't actually use it. Use absolute value notation. No, sorry, it was question 1. I had it there. Where I didn't use it was question 2. That's where I forgot. So this even index, we've got an odd power, so this does need to be in my absolute value symbols, and this needs to be in my absolute value symbols. Exponent form, and we did it this way. Okay, so this and this, these are the same. Okay. Okay. Where were we at now? 7. Okay. Now 7, simplify is already written as a quantity cubed for us. We don't have to worry about the absolute value. So this one just required the step. Cube root undoes my cube power, and this one would just be x minus 7. And so absolute value not necessary. Some of y'all put it, some of y'all didn't. I just let that one be. Okay, 8. Rewrite the expression as a quantity raised to a power of the denominator in the rational exponent, then simplify. Okay, so again, this is not just about the answer, it's about the manipulation. One half undoes the second power, or the second power undoes the 1/2 power, or 2 times 1/2 is 1. Okay, rewrite expression as a quantity raised to power of the denominator of the exponent, then simplify. Same thing. I believe it's going to be 4. Let me double check. And so calculator assist says that you can come in and use your calculator to find out. You just have to show me the work. There we go. So I thought 4. So 4 to the 4th raised to the 1/4 power gives me just the 4. Okay, 10, use rational exponents. Okay, show the step of writing the rational exponents. That's what I was looking for. And use rational exponents to simplify. And very importantly here, parentheses are required to be part of the answer. So we would have 16 over 2. Okay, this is final answer. And then this would be equivalent. And here we would use our product to a power rule. And that would give us a to the 8th and b to the 8th. So this is the only one that I needed, but the other one would be okay also. All right. I think I got all those. Yep. Thanks, everyone.